I'm Ryan Tomastik from the University of Connecticut, and I'll be talking about the nuclear power system and its autonomous power control. The overall MCVT diagram is shown here, with the power system located here connected to the following subsystems. Depending on the power request received by the internal communication network, the power distribution system will send available power generated to ECLSS, structural, and interior environment systems. The power system is also capable of receiving dust accumulation from the exterior environment system, as well as an intervention agent from the human/robot agent system to clean it. The nuclear model used within the power system is that of an SP100 nuclear power system. It is a physics-based model based off of the thesis of Justin Langlois, with schematics shown here. It consists of a reactor, a primary loop, a secondary loop, and radiator panels, each with temperatures as labeled on the figure. The model was used to develop discrete time state space models in order to predict process measurements and ultimately detect anomalies. For damageability, the effects of dust accumulation were modeled. The heat rejection would be affected by the dust accumulation, which would in turn degrade the power generation. Therefore, for the given dust accumulation, the heat rejection fraction of the nominal value is determined. This will be a value between 0 and 1, with 1 being the nominal case. 21 discrete time state space models were developed to generate the temperature values for different dust levels, and based on the current dust level, the appropriate nearest neighbor models will be chosen by the system. The outputs of these models are then interpolated to achieve the value for any continuous dust level, and those interpolated values are used to calculate the power generation. When there is too much dust, an intervention agent can be called for. This would cause the dust to gradually be removed, resulting in restored power generation by the end of intervention. Finally, to talk about the power distribution and storage system, which can automatically redistribute the power generation to meet the requested power demand by the loads, using an automatically changing gain. One of 3 scenarios will be happening at any given time, depending on the difference between the load request and the total power available, and the power distribution system can handle any combination of them. In scenario 1, the nuclear power generation alone can provide sufficient power to the loads. In scenario 2, the solar and nuclear power generation together can provide sufficient power to the loads, and the power is redistributed based on the shown gain calculations. Then in scenario 3, the solar and nuclear power generation cannot provide sufficient power to the loads, and thus all of the power generation is needed. In the first 2 scenarios, any excess power can be used to charge a battery, and then in scenario 3, the battery will be drawn from to make up for the loss of power. Thank you for listening.